Okay, guys, here we are, lesson 6-7 on equivalent expressions. So we had talked, and today's date is the 15th. So we had talked about how the distributive property, oh, there's Patches saying hello, talked about the distributive property and how it is very important in order for us to do work with, go away, don't step on my board, do work with variables. In addition, there's 3 key things you can do with it. So we're going to kind of review the first 2, and then we'll launch into this new one, the equivalent expressions, which are like, hey, Rosner, I already know about equivalent expressions. 2 expressions that have the same value, but it's different. Okay, so let's talk about and remind ourselves about distributive property. That was from our first set of notes. Property. Let's see, when did we take those notes? Tuesday? I think it was Tuesday. So the thing about distributive property is it uses multiplication very important, obviously. Uses multiplication to remove parentheses. That's the whole point behind this, is to get rid of the parentheses. To remove parentheses. So an example of that would be 3 times the quantity x plus 7 equals, and then we're going to distribute that 3. So we're going to get 3 times x, and then inside it says plus, and then we're going to have 3 times 7. And then if we simplify, we get 3x plus, and 3 times 7 is 21. Okay? Now, let's look at what we talked about in our last set of notes, also from the same lesson 6-6, and that was factoring. Factoring. And factoring is the opposite, if you think about it. Not opposites, opposite of the distributive property. Okay, so if you think about, if the distributive property is using multiplication to remove parentheses, we're going to use the opposite of multiplication, which would be division. So uses division to put parentheses back into an expression. Okay, so if you remember, basically what we're going to look for is the GCF times the remaining expression. Okay, so let's do an example of this one. So we have 27x plus 36. So I want to think of what is the GCF of 27 and 36. And it turns out that the GCF is equal to 9. So what I'm going to do is divide both of these terms by 9. Excuse me. And that's going to give me 9 on the outside, and left behind is 27x divided by 9 is going to be 3x, and then a plus, and 36 divided by 9 is 4. Now we got to be cautious when we are factoring. One of the things that can happen is we find a common factor, but not the greatest common factor. So we need to make sure that when I look in my remaining expression, that there aren't any factors that they have in common, because that just is a hint. I need to go back and deal with it. Okay, now I'm going to go to the next screen so that everything that I talk about deals with our new idea with the equivalent expressions today. You're still on the same page. So what we're going to talk about here is, what if I have this problem? 3x plus 7 plus 3x. So what I want to do is to go through a list of vocab words that are super important for us to understand. Okay? So let's start with term. So a term is a number, a variable, or a product of numbers and variables. It can be a number with a variable, right? So in our example term, there are 3 terms. They're the ones that are separated by the operation signs, okay? So it's a number, a variable, or a product of numbers and variables. So I'm going to write here a little note. They are separated by plus and minus signs. That's going to be a good way to notice them, okay? So I'm going to give you just some examples of generic ones. So it said a number, so we could say 3. It said a variable, so we could say y. It said product of numbers and variables, we could say 15x. Those are all called terms, okay? So again, let's go back to this guy here. In an expression, terms are separated. So here we go again. It's so important we had to tell you twice. By adding or subtracting symbols. Okay, there we go. All right, so again, 3x, 7, 3x are the terms of this particular problem. In fact, we could say there are 3 terms. Okay? All right, so let's talk about things that could show up in a term. Let's talk about a coefficient. And you've been hearing me saying this word, so now we're making it official. So again, if you don't understand some vocab, what you can do is you can write some flashcards and memorize these, okay? So a coefficient is simply the number factor. So factor means it's part of a multiplication problem. The number factor of a term that includes a variable. Okay, so let's talk about that idea. If we have 3x, 3, the number that's in front of the variable, is a coefficient. Okay, now, I remember I said it was a factor, so just remember this piece. 3x is the same thing as saying 3 times x. So that's where it's a product together, and each of the pieces, 3 and x, are called factors. But 3 has the special name of coefficient. Okay, next one is going to be the word constant. So something that's constant never changes. So if you think about a problem, what will never change? 7. In our example, 7 will always be 7. So a constant is a term without a variable. In other words, it's a number only. So it's not a coefficient, which is part of a product with a variable. It's just a number that stands alone. So in our example, 3x plus 7 plus 3x, 7 is a constant because it's always 7. You cannot make 7 something else. 7 will always be 7, okay? Now, I've also kind of thrown around this term, so I want to make sure that we all understand it, and that is like terms. So we know what terms are. They're numbers or variables or products of numbers and variables that are separated by adding signs and subtraction signs. Uh-oh, I just saw a mistake. Let me go fix it. I, for some reason, wrote the division sign, and you heard me say it multiple times, that it was a subtraction sign. Whew, glad I saw that one. Okay, so what are like terms? Like terms are terms with the same variable and the same exponent. So it's not enough that they both say x, but if one says x and one says x squared, not like terms. So let's kind of talk about those. We'll break them into two parts. Let's look at like terms. So in the example from above, we have 3x and 3x are considered like terms. What makes them the like terms? The x's. It's not the numbers, it's the variables. All right, let's see if we can maybe give another set. How about 15y and 2y? So again, what makes them like terms? Not the 15 and the 2, but the y and the y. Okay? So in other words, variables must match exactly. Okay? So I'm going to go to my next screen, which should still be towards the bottom of your first page. If it needs to bleed onto the second, so be it. But what I want to talk about is what the whole point to creating equivalent expressions on your work tonight is going to be about. It's about looking for like terms and putting them together. So I'm going to give you a new term for that. And over here, we're going to talk about combining like terms. So it's not a term as much as it is an action, something we can do. Well, we know what like terms are. There are two terms that have the same variable with the same exponent. Combining them means we're going to have to do some sort of math. And the math we're going to do is we're going to add or subtract. So we're going to add or subtract the coefficients of the like terms. Okay, so they got to be like terms or we can't do it. Now, something we need to make sure that we understand, okay? Variables never change. So when I add two terms that have the same variable, the variable is not going to get squared or anything like that. It's going to stay the same in adding or subtracting. Okay, so here's what I need you guys to understand is that I kept saying, hey, everything we're going to be talking about, these 3 videos, has to do with the distributive property. So how come I'm not talking about the distributive property right now? Well, here you go. So you know that original example. 3x plus 7 plus 3x. So what I'm going to do is use my commutative property and change the order so that my x terms are next to each other. And the constant is going to be at the end. Now this is pretty standard to always have the constant at the end. So I'm going to write that little note here. Constant needs to be the last term. Now, that is if there are any constants, okay? Sometimes there may not be. Now, here's where you're going to see how the distributive property starts to work. We're going to combine those two terms. Now, what we're going to factor out, and before, when we were doing factoring, we did GCF. But what we're going to factor here is the variable. So I'm going to factor out the x. So what does that leave behind? Well, 3x divided by x is a 3, and then it says plus. And 3x divided by x is a 3. Okay? Now, we still have the plus 7 at the end. Nothing's happening with him because he has no match. Poor guy. Lonely on Valentine's Day. I know, and I said the date's 2/15, but I'm making the video on Valentine's Day. So when I add 3 plus 3, I get 6. The variable stays x plus 7. And there is the magic. Whoop, 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 whoop. So that's what we're going to practice. And just a couple things I want you to think about when you are writing out answers. If you have more than one variable, you need to go in alphabetical order. With the variables. Okay, that's something that we're going to be thinking about. Okay, keep that in mind. Also, constant at the end. Okay, all right, so I'm going to go to what would be page 2 for our examples. Our directions are going to ask us to simplify. And here's what simplify actually means. Do all the math until there's nothing left to do. So we're going to try to do everything mathematically possible with our problems. Okay, so think about all the things I just showed in that small example. We've got 14y plus x plus 22y. Okay. So I see some x, an x term, and I see two y terms. Now, we're going to go alphabetical, so I'm going to use my commutative property to change order, and that gives me x plus 14y plus 22y. Okay, next, I'm going to use my associative property, and I'm going to do the math where I can. And the only place I can do math is with the y's, because I have more than one set of values with y. Now, x has no partner, sad boy, so he's all by himself. But what we're going to do is factor out the variable y, and that's going to leave behind, actually, I'm going to give him, I'll let him be black. How about that? We're going to have a plus in this middle there. And we're going to have 14y divided by y is 14. So the coefficient shows up. 22 divided by y is 22y divided by y is 22. So again, what happens is when I combine combine my like terms, I'm only doing math with the coefficients. Variable doesn't change. So I get x plus 14 plus 22 is 36y. And there's your answer. Second one, we've got 3x plus 9y plus 5x. So what do I have that are like terms? X's. So I'm going to do the commutative property, and that's going to switch the order so that my x's are going to be next to each other, and the y at the end, because it's alphabetical order with the variables. I'm going to use pretty much the associative property in a sense here, and I'm going to factor out the y. Okay, I'm going to factor out the y. So I have a y here, and we're going to have plus in the middle. So when I take 3x and divide, sorry, I pulled out a y, and it's not a y, it's an x. Sometimes my brain, I tell you. Do you ever have a moment like that? I do. And then I forgot to add the 9y. Yeah. Okay, let's try this again, shall we? So 3x divided by x is 3. 5x divided by x is 5. So we do our math. 3 plus 5 is 8. So we get 8x plus 9y. I don't have like terms, so I'm done with this problem. Bada boom, bada bing. Okay, let's do another one. Oh, look at this. It told me to simplify. I thought I was just going to do a lot of this looking for like terms and combining them, and all of a sudden they show a problem from 2 days ago. So, well, that's fine. Let's get rid of parentheses. It didn't specify what we were going to do. It just said simplify, which says do all the math until there's nothing left to do. Well, in this particular case, I'm going to distribute, because I want to get rid of those parentheses. So I'm going to have 7 times 3x, and then it says plus, and then I'm going to have 7 times y. Now remember, this is a brain step, so you could go from the original problem to this final answer of 7 times 3 is 21, and we get the x as part of that, and then we have 7y. So that's a different thing that could happen when the directions say simplify. And then we have, oh, let's do the other thing. So right here, we have an example of each of the things that the distributive property allows us to do. Allows us to factor out a variable so that we can combine the coefficients. It allows me to distribute, to get rid of parentheses. And factor is our last one. So we have 12x plus 8y. So let's see, GCF. What can go into both of those guys? I'm thinking 4. So let's try that. Hold on 1 second. Sorry about that. Heard Tiana call for me, and I forgot I was making chili for tomorrow, and the dinger was going off, and I didn't hear it. All right, so what I'm going to do is divide 4 out of each of these numbers. So when I factor, it's going to be a product of the GCF and the remaining expression. So 12x divided by 4 is 3x, plus 8y divided by 4 is 2y. And there's the answer there. Now, I'm going to go to the next page, and, sorry, Patchy's making noise, and I am going to write out the problem off screen. It's just going to appear, and then I'm going to have you guys pause and write it down for yourself. So, see you in just a few. Okay, so this one's a bit of a doozy. It's the farmer's market sells fruit baskets. Each basket has 3 apples and 1 pear. Use A to represent the cost of each apple and P to represent the cost of each pear. Write and simplify an expression that represents the total cost of 5 baskets. So we got a lot of words here, so let's kind of nail down what's the most important. So first thing is it talks about each basket has 3 apples and 1 pear. Then they define some variables for it. So A represents the cost of each apple, and P represents the cost of each pear. And the last thing that it tells us is that it wants us to represent the total cost of 5 baskets. Okay? So let's figure out what it costs for one basket. So it says that there's going to be 3 apples, and we're going to use A to represent the cost of 1 apple. And then there's also 1 pear, and so we're going to have P as the cost of 1 pear. Now what we want to do is figure out how much it's going to cost for 5 baskets. So that's going to be our expression. So 5 is the number of baskets. $3A is going to be the cost of 3 pears, or total cost of pears, or sorry, total cost of apples. And P stands for the total cost of pears. Oops. Helps if I get the right pear, right? And then remember what's inside the parentheses stands for. That's 1 basket. Okay. And so what we're doing now is figuring out how much it would cost for 5 baskets. So I'm going to rewrite that. 5 times the quantity, 3A plus P. So that's the first part, is to write an expression. But now we're going to simplify it. And to simplify, we're just going to go ahead and distribute. So 5 times 3A plus 5 times P. Again, that's your brain step. And the final answer is 15A plus 5P. All right, enjoy this, guys. Oh, by the way, special word of the day, birthday, as in happy to you. Okay, and why would I tell you this? We've got 2 birthdays this weekend that we're celebrating. Mine, Sunday. My dad's, Monday. That's how it's going to be. Birthday weekend. All right, so birthday at the top. See you guys.